So you'll have the benefit of this explanation. Let me go out to a piece of paper and maybe make you a few notes that might be helpful. Okay, so you've asked me about what is a variable. And in a sense, if you relate it to algebra, the variable is the unknown. So it becomes what you want to know about. It's the item or the thing or the person that you want to know about, that you're interested in. Typically, the easiest way to recognize it is to think about what kind of question you would ask somebody. If you were responsible for conducting that research and collecting the data, and the data are the responses to the variable, think about the question that you would ask in order to get that particular response. So you want to think about the question that you would ask. So for example, if I, were to walk up to someone on the street and I say, well, what is your favorite TV show? Then my variable for that particular research study is the TV show. Now, my measurement for that particular individual is the favorite. Okay, so really my variable is what is a person's favorite TV show. And again, remember, you want to add as much detail into the description of the variable, the description of the population, the description of the parameter. The details are important within the realm of statistics because it helps to give your research context. So again, another example, let's say I walk up to somebody and I say, okay, what is your political affiliation? If I can remember how to spell it. Oops. Left out an I there. Affiliation. Okay, so my variable in that particular scenario would be the political affiliation. And I would likely get responses such as Democrat, Republican, or Independent. Sometimes you may want to pose the question and provide possible answers, because probably if you walk up to somebody and ask them their favorite TV show, the answers and responses are going to be all over the place. So perhaps you give them a list. But the variable itself, one way to think about it is when you're doing research, you got to think about, much like you do when you're writing a story or something, is you have to think about who, where, what, when, and why. And the variable is your what. It's what you want to know about. Is that better, Natalie?
Yes,
Sorry.
thank you.
Rachel, did you have a question?
I do. So favorite can be included in that, because I didn't know if that was just the measure, because when I was doing the practice problems, that's one of the questions I got wrong, because on the variable I put the average grade on college exams and just the grade on college exams was the answer.
Okay, the variable, it kind of depends. You have to almost look at the context. When you're talking about things like average or a percentage or proportion, that is likely your measurement. In this particular scenario, in this statement, what is your favorite TV show? that's not really the measurement. That's kind of the opinion of the person you're asking. Because if I were to ask you, what is your favorite TV show? What you consider to be your favorite would be different than, say, my favorite or Natalie's favorite or Dominic's favorite. So in this sense, the word favorite is sort of the measurement, but that measurement is with respect to the person you're asking.
Okay, thank you.
Okay, I saw something come up in the chat, so let me see if I can see it, because I usually can't see the chat when we're in share mode. Okay, other questions from last week's discussion, from your homework, from practice problems? Okay, one thing I want to remind you about, if you haven't, and I haven't looked to see who has and who hasn't, but if you haven't completed the orientation quiz for the course, I need you to do that before Friday. That is the mechanism by which I can check attendance. We're required to have you complete an assignment. It's worth 10 bonus points. It should take you less than 5 minutes to do it. Again, to find it, there's several ways you can get to it. For me, the easiest is go to the home page for the course, to assessments, scroll to quizzes, which provides you with a list of all the quizzes, and under the very first one is the orientation quiz. There are no math problems. It's all questions related to the course syllabus, which I hit the highlights of last week. If you were not present for that part of the presentation, then you may want to actually review the syllabus itself. But if you haven't taken the opportunity to do that, if you would do that before Friday night at 11:30 p.m., that would be wonderful. I have to report attendance by Monday. Okay, so I want to remind you about that. Yes, ma'am.
I'm sorry. Never mind. Actually, where are you storing the recordings for the lessons?
I'm not sure. I'll probably likely create a folder and just put them in the folder and try to put the dates and the topics that we discussed. I'm not sure that I ever got last week's posted. I got it processed, but I didn't get it posted, and I do apologize for that. So what I'll do, Rachel, is on this home page under content, I'll make us a folder that says Zoom recordings, and then you can find that way they're all in one location and you're not having to go different places. Will that be okay?
Yeah, that's perfect. I just didn't know if you posted it yet or not.
I'm sorry, I forgot.
No, that's fine.
Other questions? Okay, today we're going then to pick up the discussion, and hopefully we're going to get through the two topics today are types of data, and then also the statistical research vocabulary. And I'm going to start with the PowerPoint for the lesson on types of data, but then I want to go over and actually do some handwritten notes for you so that hopefully you can see how things are connected and related. So if you want to take those notes by hand, you may want to have some paper handy in just a few minutes to do that. So we're continuing in module 1, and again, remember we talked about how that statistics has its own unique language or unique set of vocabulary, and we need to continue a discussion of that vocabulary so that we can communicate, because we're going to be using the terminologies and these terms throughout the semester. So today's topic is types of data. And really this is kind of a one topic that can be carried over into other subject areas. For example, in biology class, you often learn how to group or classify animals by their kingdom, their phylum, their class, orders, families, genera, and their species. And so I have a picture of a dolphin here. It is a member of the animal kingdom. It is in the phylum, the Chordata. It is a mammal. The class it's in is a mammal. And there you see the order and the family and the genera and the species. So we learn to do that in biology. You also learn to do it in botany. I would anticipate that you do it in chemistry with different chemicals and their chemical makeups and what characteristics they have in common or do not have in common. Here's an example of one where you're classifying plants, and you have some plants that do not make seeds and some that do. So again, it's this idea of classifying or grouping data shouldn't be foreign to you because you have done that type thing in other classes. So classifying data, we classify data really in two different ways, primarily by its different characteristics. And you may think, well, Ms. Ralston, who cares what kingdom that a dolphin's part of, or what class or whatever, and the same thing with data. Who cares what kind of data you have? Because it's important to know from the beginning of your research what type of data you have or are given, or what type of data you're actually going to collect for yourself if you're actually beginning the process of conducting a research study. Because the type of data you have can determine what type of analyses you can and cannot do on down the road. So if you know you want to perform a particular test, and that particular test maybe requires you to have numbers, then you need to pose your question in such a way that you're going to get a numeric response. So it's important from the beginning to know what type of data you have. And again, there are two methods by which we classify data, and it's based upon the characteristics of the data, but we do it by type, and then we also do it by level of measurement. And again, both are important because, again, it gives you that idea of what type of analyses you can and cannot do on down the road. Now, remember that data, we talked about data last week, data is the actual responses that you get to the variable. We talked about the variable just a few minutes ago. The variable is what you want to know about, and likely you would pose a question either verbally to someone, perhaps written on a survey, but you're going to pose a question, and the response that they give you becomes your data. Okay, so I want us to talk about first how we classify data by type, and then how we classify it by the level of measurement. And there is some overlap or connection between those two methods. And all of the information that I'm about to share with you is on the PowerPoint, but I want to go out and draw you kind of a diagram to help you get a sense of, okay, this is what this looks like, and this is what was going to, what we're going to see when we classify data. Okay, so I'm going to kind of draw us a picture here so you can get a sense of what's going on. So our overarching theme, or our topic of discussion, is data. Okay, and remember, data is the response, or the responses, to the research question or specifically to the variable. And when you think about data in terms of type, there are primarily two different types of data. So I'm going to draw two different branches, sort of like a flow chart. The first type of data is called qualitative. Sometimes it's called categorical. That's another term you might see. But if you notice, qualitative is an adjective. And within that adjective, you have the noun quality. So qualitative data, or what's sometimes referred to as categorical data, is data that is primarily words or phrases. Okay, so qualitative data, the response, that would be a response to the question like, what is your favorite TV show? Or what is your political affiliation? So it's going to be typically words or phrases, but you have to be careful because it could be a number or numbers. But typically, if it's a number with which we would not calculate. You would not perform calculations with this particular number. Typically, it's a number that's being used to identify a person. For example, if you're a basketball fan and I say, okay, who wore number 23? Most of you or some of you might tell me that that was Michael Jordan. You have, the government identifies you by your social security number. Georgia Highlands identifies you by your GHC number or your 900 number. So it could be a number, but it's a number that's being used as a label or as a tracking mechanism, and it's not something we would normally calculate with. So typically with qualitative data, again, because it is words or phrases, we're not going to perform calculations. Okay, so you can't really do math calculations here. We can talk about perhaps which category or which phrase occurs the most. We could talk about which one occurs the least, and you could give it a sense of ranking, maybe. Again, depending upon what it is you're talking about. Okay, so qualitative data is words or phrases, maybe a number that's used for identification or tracking, but typically you're not going to perform any kind of calculations. Now, I mentioned a couple of examples. I didn't write any of those down for you. So examples might be things like your favorite TV show, your political affiliation. It could be your eye color. It could be gender. It could be your zip code. Your zip code is a number, but again, we don't normally calculate with a zip code. It could be your social security number. It could be your GHC ID number. Let's see, it could be your ethnicity. Okay, so those are just some basic examples of qualitative data. Okay, so since I can't see your faces, let me pause for a minute. Do you have questions about qualitative data? Qualitative data, again, is data that can be grouped into categories. It's typically words or phrases, and maybe could be a number, but not one you would calculate with. Any questions? Remember, I can't see your faces or the chat. Okay, going back then, the big category, the other category of data is quantitative. Okay, so data is our overarching theme. The first category is qualitative. The second category is quantitative. And again, if you realize that that is an adjective, and it basically contains the word quantity. Okay, so typically your quantitative data is going to be numbers. And it's numbers associated with either counts or measurements. Okay, it's going to be numbers. And again, it's associated with counts. Oftentimes in the description, it might even say number of, like the number of students in the class, the number of eggs a hen lays. It could be a measurement where you're measuring temperature or height or weight or blood pressure. So quantitative data, again, that idea of it being a quantity, it is definitely going to be numbers that we calculate with. So we can actually, with quantitative data, with quantitative data, we are able to calculate. We can perform basic calculations. We could talk about the average height of people, the average blood pressure, the average temperature, the average number of students in a class, the average number of eggs that a hen lays. So again, with quantitative data, you can begin to perform calculations. And again, it's things associated with either a count or with a measurement. Some examples, again, you might have weight. You could do height. You could do the number of text that you get within a day or within an hour. You can do age. You could do the number of siblings that you have. We can talk about blood pressure. That's a number. Okay, so qualitative data is words or phrases, maybe a number, but you don't calculate with it. Quantitative data are things that are associated with counts or measurements. Questions? Quantitative data, if you have quantitative data can actually be broken down further into two additional categories, so that ultimately you have three primary types of data. You have qualitative, you have quantitative discrete, or you have quantitative continuous. So what's the difference? How do you know when it's discrete, and when it is continuous? Quantitative discrete is usually going to be whole numbers or whole units. And the description is the one that usually would say number of, like the number of eggs, the number of text, the number of siblings. And you're going to get answers like 2, 3, 4. You can't get half of a text. You can't have a quarter of a sibling. Okay, you either have one or you don't. So continuous data is whole units. Usually we'll have the phrase number of in there. Again, as emphasis, it has no fractions, no decimals. Continuous is more associated with measurement. I always think about the word continuum, where if I'm thinking about some sort of measuring tool, I can break my measuring tool down into smaller and smaller units so that I could measure in 1/8 of an inch or 1/16 of an inch, or, you know, a half a pound, a quarter pound. So with continuous data, more times than not, it's going to be associated with measurements, but you can have a fraction or a decimal or part of a whole. So this would be more like the amount of milk that a cow gives in a day, your weight, even your height, because we normally talk about heights. We would say something like, I'm 5'6". So typically continuous is associated with a measurement because you have to use some sort of measurement tool, and it will give it to you in parts of a whole, like with a fraction or decimal. Even temperatures, you know, depending on what you're doing. Typically for your body temperatures right now, you get 1 decimal place. The average is 98.6 degrees Fahrenheit. But we could talk about the amount of rain, and you can have parts of inches. But sometimes, again, those things sometimes in reality are perhaps expressed as a whole number. But again, you have to think about how they're actually measured. So you have 3, in terms of types of data, you have 3 categories. You have qualitative, quantitative discrete, and quantitative continuous. Any questions? Okay, if not, then let's move on to the levels of measurement. Okay, the levels of measurement. And again, there is some connection here, and I'll try to show it to you as we go. For levels of measurement, I want you to think about a set of steps or stairs. Okay, so we're still talking about how to classify data, but we're going to talk about it in terms of the level of measurement. And there are actually 4 of these. And again, I want you to think about it as a set of steps. And my lines are a little crooked. A set of steps. The 4 levels are nominal, ordinal, interval, and ratio. And let me make one connection at this point. If there's 4 steps, and if you divide the steps in half, so between nominal and ordinal, okay, or not nominal and order, excuse me, between ordinal and interval. Okay, so you got 2 steps below the line and 2 steps above the line. The first 2 steps correspond to data that is qualitative. Okay, so if you're going to be on level 1, which is nominal, or level 2, which is ordinal, you're going to have qualitative data. For interval and ratio, once you hit that 3rd step, now you're talking about quantitative data. Whether it's discrete or continuous, you're talking about quantitative data. So that's one thing that can help you out, because if you've decided from the beginning that you have qualitative data, which is words or phrases, maybe a number that we don't calculate with, then I'm only going to consider whether or not that particular data would be nominal or ordinal. Whereas on the other hand, if I have numbers that we calculate with, which is quantitative data, whether it's discrete or continuous, then I'm only going to consider whether it's interval or ratio. So that's one of the connections, or that is the connection between the 2 different measuring tools. So let's talk about these different levels. Nominal, and you may not know this, but nominal is the adjective form of the noun name. So at the nominal level, these are simply categories or groups. There's no sense of order. One group is not necessarily better than another. You know, again, we could think about this. An example would be your political affiliation: Democrat, Republican, Independent. While you may have an opinion about that, okay, in reality or in the context of levels of measurement, being a Democrat is not necessarily better than being a Republican, which is not necessarily better than being an independent. They're just groups. Again, you can think about gender. Male, female, the biological options, male and female. Again, one's not better than the other. They're just categories. There's no sense of order to them. Because we are dealing with, at that point, we are dealing with just categories and it's words and phrases, we do not perform any calculations at the nominal level. Again, at the nominal level, you could tell me which category occurred the most, which one occurred the least. You possibly could rank them, put them in order. You know, if you want to think low to high or high to low, you know, think about which one occurred the most and then which one was next and so forth. And in that sense, you could give it a sense of ranking. And again, some examples there would be the idea of gender, even your social security numbers are at the nominal level. We would not normally put people in order by their social security number or put them in order by their GHCID number. Those are randomly assigned to numbers, so to speak. So you wouldn't try to order them. As you move to the next level, which is still qualitative data, words, phrases, now you have the categories or groups, but you have a sense of order. Okay, ordinal is the adjective form of the noun or the verb order. So this would be, think about sometimes when you have to do surveys and they give you the option: strongly agree, agree, neutral, disagree, strongly disagree. Again, there's a sense of order. Now, it's open to interpretation. Perhaps. Think about movie ratings. You have G, PG-13, PG, R, X, so again, you have a sense of ranking. It could also be like a pie baking contest. Who gets first place, who gets second place, who gets third place. And again, that's where the interpretation comes into play. Anything that's kind of in that judging realm, it's open to interpretation. That those judges, if you had a different set of judges, you might get a different set of order. So it's open to interpretation. But again, we're still dealing with primarily words and phrases, so you're not going to perform really any kind of calculations. Again, you could tell me which one occurred the most, you could tell me which one occurred the least, and you definitely could give me a ranking, but those rankings are open to the interpretation of, say, the judge. Any questions? Guys, remember, I can't see your faces to know whether you're understanding, and I can't see the chat. And I'm not bothered if you interrupt me while I'm speaking. I'm trying to take enough pause time.
I'm good. I'm just writing this stuff down.
I have a quick question.
Yes, ma'am.
So both nominal and ordinal are categories and groups, and they have rankings from most to least. So,
well, really nominal, we wouldn't do rankings. We could talk about which one occurred the most or which one occurred the least, but we wouldn't necessarily rank them. Mm-hmm. The primary difference between nominal and ordinal definitely has that sense of order. You have a first place, a second place, a third place.
Okay, thank you.
Other questions? Okay, as you step from the second step, which is ordinal, to the third step, which is interval, you cross the threshold, and now we're dealing with numbers. Okay, so now we're dealing with numbers. At the interval level, so we have numbers. So you're still going to have, even with numbers, guys, we can order numbers. I mean, we know 1 comes before 2, 2 comes before 3. So you still have that sense of order. I have lost my train of thought for some reason. Let me go, so I don't misspeak. Let me go out here to the PowerPoint because my thought has just left me. Sense of order. Okay, so again, obviously with interval, because you have numbers, we do still have a sense of order or ranking. Again, because I know that, 1 comes before 2, 2 comes before 3. We can do that sense of ranking. But again, the challenge with interval sometimes is that those rankings can be open to the interpretation of the person. Okay, so you still have that, again, that sense of order and ranking, but again, it's open to the interpretation. But because we're dealing with numbers, we can begin at the interval level to add and subtract. I could talk about, how that Susie is so many inches taller than Johnny, or that Stephen is 3 years younger than Evelyn. So you can begin to make comparisons through addition and subtraction, talk about which one is more, which one is less, shorter, taller, those kind of things. The other piece here that students find often challenging with the interval level is that there is no true zero. And again, that's often a hard concept for students. At the interval level, zero is simply a placeholder. Typically in our minds, when we hear the word zero, I immediately think, okay, there's none of it, there's nothing, you know, zilch, there's just nothing. So that's what we mean by a true zero. A true zero would imply that you have none or nothing. But at the interval level, it doesn't necessarily mean that. For example, an easy example to relate to. If we were to say that it's 0 degrees Fahrenheit outside today, that does not mean there's no heat or no temperature. It simply means that it's really, really cold. Okay, so to have a temperature of 0 degrees doesn't mean there's no heat or no temperature. It's just that's the point at which we began measuring. Typically at the interval level, you could have negative values because we can talk about having a temperature below 0. Another example that you might relate to is if you think about IQ scores. If we say that your IQ score is 0, that does not mean that you have no brain or no intelligence. It might mean you're just not a good test taker. It can mean other things as well, but it doesn't imply a score of 0 on the IQ test does not imply you have no brain or no intelligence. Again, that's maybe just where the measurement began. Even with years, we are currently in the year 2021. Well, how do we know it's 2021? We know it's 2021 because at some point humanity began marking off the years. And so at some point in history, there was a year 0. But year 0 does not mean there was no year. That is the placeholder or where we began marking off time. Again, think about it because we often talk about BC and AD. So again, 0, at some point you had to hit 0. So I've tried to give you a couple of examples of interval, things like temperature, IQ scores, years, or counting off time. What was the other example I gave you? The temperature and the IQ scores are probably the two most common. Okay, then at the ratio level, the last level, which is ratio, let's see. Again, we still have numbers because it's going to be quantitative data. You can still have that sense of order or rank, but now we can begin to measure those differences between them. Again, at this point, you can add and subtract. There's not much interpretation left here. You can also multiply and divide at the ratio level. So we could talk about how that Danielle is 4 times younger or than her mother. We could say, you know, Laura's age is 4 times that of her daughter. So you can begin to make comparisons like ratios. Again, the idea of ratio is a comparison. So we can begin to think about it in terms of multiplication and division as well. Again, with that sense of ranking, we can begin to look at those relationships, and those relationships are a little bit more set in stone than usual. The other thing about the ratio level is that true zero exists at the ratio level. So at the ratio level, the idea or the concept of a zero would mean that you have none of something or nothing. And this is sometimes confusing to students. One of the questions I got last week from an online student about this level of measurement was asking about the area in square yards or in square feet of your neighbor's yard. So it was asking, you know, basically, what's the size of your neighbor's yard? Well, technically, it could be 0 square feet. And 0 square feet would imply that your neighbor has no yard. So you have to be careful. You have to think about it kind of in some ways outside the box, but think about it. What would it mean to have 0 of something? For example, in this class, your textbook is free. So we would say you paid $0 for your textbook. Well, in this case, 0, or in that case, 0 means none or nothing, which means we're at the ratio level. The CEOs with a salary, if they work for free, their salary could be $0, which means they're making no money. Okay, so at the ratio level, you begin to have that true 0. And again, that's, for me, that's the primary difference between interval and ratio. Is I want to, if I've got numbers so that I know that I have quantitative data, the first thing I'm going to ask myself is, what does 0 mean? And it comes down to, does 0 mean you have none or nothing, or is it simply a placeholder? And that's how you distinguish between interval and ratio. Now, I want to go out and take a look at some examples. Again, it's not that you've got to reiterate all this stuff to me or draw this diagram again or whatever, but you got to be able to apply it to a particular scenario. Okay, so let me go out and let's look at some examples. Which I guess if you're looking at the PowerPoint, you have the answers. Okay. So you got to be able to do this like on your homework. These are like multiple select is what they call it, because you have to select more than one answer. You're going to choose 2 answers for each one because you have to choose whether it's qualitative, quantitative discrete, or quantitative continuous. And then you have to decide, is it nominal, ordinal, interval, or ratio? Okay, so the first one is the number of books students carry in their backpacks. Is it qualitative, quantitative discrete, or quantitative continuous? Is quantitative discrete couple of things give it away. One, it says number of, which implies we're counting, which gets me to quantitative. It's discrete because I'm thinking about a book, and you can't really have 3/4 of a book or half a book or a quarter of a book, so you can't have fractions. If I think about the level of measurement, since I know that it's quantitative, I know that it has to be either interval or ratio. And if I think about it, what would it mean if I had 0 books in my backpack? That means I have no books in the backpack, which means it's at the ratio level. Now, some of you may find in D2L, under the lesson for types of data, I created a flow chart, and for some of you that may help you make a decision. It walks you through kind of that thinking process that I just went through with that particular example about the number of books. Let me see what the next example is, because I don't remember. Okay, the next example is the weights of the backpacks. So if I'm using this flow chart, okay, and I know my question is weights of backpacks, I'm going to ask myself, what kind of responses do you have? Well, I don't have words or phrases for weights. I don't have numbers with which we do not calculate. I have numbers with which we calculate, because I would calculate with weights. So that gets me over here to this third option on my flow chart. And so then I know it's either going to be quantitative discrete or quantitative continuous. Weights are a measurement, and I could get a decimal or a fraction, which makes it quantitative continuous. And then because I know it's quantitative continuous, I know ultimately it's going to be either interval or ratio. And again, here's where kind of it maybe gets a little weird. If you say, okay, the books weigh 0 pounds or 0 ounces, what does that mean? And again, it sounds weird, but that would mean you have none. You have nothing. So because you have none or nothing, that puts it at the ratio level. So some of you, it may be to your benefit to print this particular flow chart and walk through it each time. If we did the colors of the backpack, okay, again, thinking about what kind of responses I would get. If I were looking for colors, it might be things like red, blue, black, multicolored. Okay, so I'm getting words or phrases, which means I have qualitative data. And then I have to decide, is there a sense of order? Is having a red backpack better than having a black backpack? Not really. Maybe it's just a personal preference. So we would say no, which means it's nominal. So the colors would be qualitative and nominal. So again, that flow chart is in D2L. And I'm trying to go there, maybe. But it's inside D2L. It's not letting me go over to D2L right now for some reason. Okay, there it is, thinking about it. So if you went under the lesson, this is module 1, types of data. On that landing page for data, it has types of data flow chart. Okay, so I would encourage you to print that off and walk through the problems using that particular item. Okay, any questions before we move on? I'm moving on then to the next lesson, which gets into, again, some additional vocabulary related to statistical research. Okay, this is more of if you were reading a study or if you were conducting a study yourself, what's some of the terminology or vocabulary that you would encounter? And again, you may be asked to do that in some of your other classes like psychology and sociology, even history. I've heard where they've had to do research. So again, it's to your benefit to be familiar with this language. Okay, I'm going to skip the objectives. Okay, typically with statistical research, or really with any kind of research, your ultimate goal is to answer some question. There's something that you're interested in and you want to maybe know what has happened in the past so that you can perhaps predict what's going to happen in the future, or try to figure out why a particular thing is occurring in the present. So the primary purpose of any kind of research is to answer a question. It could be things like, does aspirin reduce the risk of heart attacks? Is one brand of fertilizer more effective at growing roses than another? Is fatigue dangerous to a driver, as dangerous to a driver as the influence of alcohol? Okay, so typically that research is going to look at perhaps the relationship between two different things. Okay, typically it's at least two. You could have more than two. A lot of times within research, they'll maybe look at 4, 5, 6. They could do 20 different things at one time so that they're able to collect a lot of data, and then can perhaps use that data for several different research projects or research questions. But it's important, guys, even from the beginning, that you are able to identify your variable, your population, your parameter, your sample, and your statistic. But it's also important that you set up your research study properly from the beginning so that whatever results you get, we know are reliable and they're also accurate. You're not just making things up or pulling things out of a hat. So there are primarily two different types of statistical research, or two different types of statistical studies that can be performed. The first of those is what we call an observational research study. Basically, observational, if you want to think about it, is people watching. You're simply observing what is happening, and you try to draw conclusions based on those observations. Now, it might be that you physically actually go somewhere, maybe at the ballpark. Again, it's like people watching, and you watch the people around you. You can also do this through records. If you have access, say, to the list of hospital records for the past year, or the list of academic records for students in the last year. So it can be, typically it's going to be what's happened in the past or what is happening currently. You typically don't interact a lot with the subjects. Again, if you're people watching, you just kind of sit back and take it all in. You don't really interact or interject yourself into the situation. And obviously, if you're looking at a bunch of paperwork or a bunch of records, you're not interacting with anybody. You're just looking at those records, either paper form or perhaps electronic. Typically with an observational study, again, you're simply observing, you're not interacting, you're not trying to change the behavior or change anything about the subjects. You're not trying to change the people that you're watching. You're not trying to change their behavior. And obviously, if you're looking at past records, you can't really change anything anyways because it's already occurred. So there's no manipulation. You have little interaction with your subjects. We can't really say, okay, because of this happened because of this. There's no cause and effect. Because of A, B happens. There's no cause and effect. Typically, an observational study will occur in a natural setting, perhaps like the ballpark or the mall, or in a hospital, those kind of things. Often your data is qualitative. Again, because you're making observations about behavior, you might say, they laughed at the joke, or they didn't laugh at the joke. They ate all of their lunch. They didn't eat all of their lunch. It can be quantitative, but again, more times than not, it's probably going to be qualitative. One of the downsides to an observational study is it can be time consuming, because you have to maybe monitor or watch people for an extended period of time to try to make some sort of conclusion based on that. So it can be expensive and it can be time consuming, because you may have to go to a particular location, to that natural setting, to collect that data. This particular type study you see a lot in the social sciences. That's your histories, psychology, sociology, criminal justice, studying, criminal behavior, that kind of thing. You also see it a lot in marketing, when people are looking to see, okay, who buys Crest toothpaste, who buys Colgate toothpaste, and that kind of thing. So you'll see these particular type studies used a lot in those two fields. Again, some examples. You've probably seen a lot of these lately with the various elections we've had over the last year, with surveys. Gosh, I would get them all the time from the Republican Party, or from different political groups trying to ask questions about it. They do it through the phone. You may get a questionnaire in the mail, especially in the social sciences with like psychology and sociology. You may do a lot of personal interviews. You also will see this in case studies. The second type of research study that we do is an experimental research study, or sometimes we just call it an experiment. Okay, so observational, again, just think you're doing observation. Again, I think about it like people watching. With an experimental research study, the researcher manipulates one of the variables, and they typically only do one at a time, and tries to determine how that particular manipulation affects the other variables. Okay, so within an experiment, you're manipulating things, or you're changing one thing, so that you can see how it is. There is typically interaction with the subject. Probably something you can relate to with an experiment would be perhaps with a new drug trial, where part of the group is given a placebo and another group is given the medication, and you look to see, are there any kind of side effects? Does the drug work? That sort of thing. So there has to be some interaction with the subjects to get feedback. Again, there are modifications because, one group gets treatment, one group does not get treatment, and they may or may not know whether or not they're getting that treatment. Oftentimes, an experiment will occur in what's considered an unnatural setting, like a classroom or some sort of laboratory, or the participants have to physically go to a lab or to a particular setting in order to get the medication. With an experimental study, we can look for a cause and effect. This medication, because they took this medication, their blood pressure was lowered. So because of A, B happens. You can, with an experiment, look for that cause and effect relationship. This particular one is used a lot, obviously, in more of your sciences like biology, chemistry, physics, medicine. You may also see experiments done in psychology and sociology, especially if they're associated with some sort of drug or some sort of medication that's being tested. Again, examples are clinical trials of new medications or of different treatments. Even within education, if you're trying to say, okay, this teaching method is better than, teaching method A is better than teaching method B, you can again perform an experiment to look at that particular relationship. Okay, so those are your two different types of statistical research, observational or experimental. Now, experimental becomes a little bit more involved because you are interacting with the subjects and you perhaps have different groups so that you can actually tell if something changes when you interject that particular medication or that particular treatment or whatever. So I'm going to skip through the examples and talk a little bit about, because I want to get to these definitions here. We got about 6 minutes. I don't know if we'll finish or not. But typically you're going to have within an experiment, and now we're focusing primarily on that idea of an experiment, you're going to have two variables. We often call them the independent variable, or it's sometimes called the explanatory variable. And it's the thing, the independent variable or the explanatory variable is the thing that's being manipulated. Whether or not you get the medication. Do you get the medication or do you get the placebo? Did you get treatment A or treatment B? So it's the thing that is being manipulated or changed by the researcher is your independent variable. The independent variable explains what's happening, that it explains why the behavior for one group is different than another group. We often represent the independent variable by the letter X. Again, that's a carryover from algebra. And then you also have your dependent variable, or sometimes it's called the response variable. It's the result. What happens when you give group A the medication? What happens if you use teaching method A? What happens when you use teaching method B? It's the result of that treatment. Typically, the dependent variable is the one that the researcher is asking a question about. So remember at the beginning of the class today, we talked about variable. That the variable in general would actually be our dependent variable. That's the one that we're asking the question about. And we often represent it by the letter Y. Again, that's a carryover from algebra. So typically you're going to have the two variables. You have your independent, which is the piece that you are manipulating, and you have your result, which is the dependent variable. In terms of setting up your experiment, they use some fancy language. Again, just fancy vocabulary. Your experimental units are the individuals or the individual object or the individual person. Okay, instead of just calling them, you could call them subjects. Some people call them subjects, but they're experimental units. Those are the individuals that are being that are part of your research or part of the experiment. Again, sometimes they're called subjects. Treatments are the different values of your explanatory variable. You got treatment A, treatment B, treatment C, teaching method A, teaching method B. You could have the group that gets the placebo, the group that maybe is going to take medication for high blood pressure. You have the group that's going to do exercise for high blood pressure. You have the group that's going to be on a special diet. So you have treatments kind of tell you how many groups you're going to have, and you have to put individual subjects into each group. Again, it's for comparison purposes. And you typically would have at least 2 treatments. You like to have kind of the placebo or the control group, okay, that's not really getting anything. And then the other, again, you have the control group. That's the group that don't receive any treatment, or they get the placebo, which gives you the baseline to begin to make comparisons. And then you have the treatment group. Now you can have more than one treatment group, but you have to have at least one. So you need a control group, which creates your baseline, and you need a treatment group, which is the group that actually gets the treatment. But again, you can have more than one treatment group, but you have to have at least one. Now, how do you go about deciding which group each person is in? Let me see if I can get through this real quick. I got 1 minute left. Ideally, your participants, your subjects, are randomly assigned to a group before you actually start your experiment. You know, maybe you just go every other, you know how you can have people count off 1, 2, 1, 2, 1, 2, 1, 2, and all the ones become the control group and all the twos become the treatment group. Again, it's just ideally you want it to be a random assignment, not really a pattern to it. If possible, you want to try to make the 2 groups as similar as possible. Sometimes that's possible, sometimes it's not. Oftentimes when we're doing research, we use a technique called blinding. With blinding, the participants, the subjects, do not know what group they're in. They don't know whether they got the placebo or whether they actually got the actual treatment. So when the subjects do not know which group they're in, it's called blinding. Now the researcher knows, okay, but again, the reason the subjects are kept in the dark is so that it doesn't, there's, not that effect of the suggestion. Oh, I'm taking this medication. So, oh, I really, so it doesn't affect the outcome. Occasionally, research is done using a double blinding technique. With double blinding, neither the researcher nor the subjects know which group is which. Okay, someone else, a third party, sets up the groups and doesn't tell the researcher, excuse me, or the subjects which group is which. Again, to prevent bias within the research. There's no preconceived notion about whether a medication is going to work or not. Okay, so I'm not quite finished with that particular lesson. Okay, so we'll try to finish that up, but I think I'm probably far enough along that you guys can perhaps look at the homework for types of data and statistical research vocabulary. Next Wednesday, which is January 27th, we will meet face-to-face in the classroom. Okay, next Wednesday, we will meet face-to-face in the classroom on the Cartersville campus. Okay, and we will pick up this discussion, and I believe we'll be getting into sampling techniques and into qualitative data. Any last minute questions? And I'll try to get last week's and this week's recording posted for you guys. All right, if not, we're about 2 minutes over. I do apologize for that, but I will see you guys next Wednesday in the classroom. And y'all have a good day.
You too.